Perfect. Recording has started. Okay, and I'm sharing my screen. Again, as I told you, today I'll repeat last lecture because it's very important, and we will add some more information, some more details, some more examples. I want you to be part of the discussion, please. Whenever you feel that you have a question, whenever you feel that you want to participate, just raise your hand and I'll give you the opportunity to discuss and to speak. All right, now this is the lecture that was uploaded to Microsoft Teams after we finish our discussion. Of course, there will be some more information, although it's repeated, and I will upload it after the lecture. Then I will update the old one. All right, so now we'll start with classes inheritance. What's the inheritance? Of course, these are the main or the two or the three phrases that you want to focus on. We have inheritance, we have superclass and derived class. Superclass, of course, we have something else. We have superclass, which is also known as the base class, okay, or the parent class. Okay, and we have the superclass, we have subclass, we have derived class corresponding to it, and parent class we have child class. Any of these is correct. It's up to you. You can use any of these. I just want you to understand what is the meaning of the basic phrases that you may face. Even when you search the internet, you will find these words using alternatively. Now, inheritance. What's the meaning of inheritance? When derive a subclass from the original class or the basic class, this means inheritance. The derived class, subclass, child class will inherit all the attributes and method from the original class, which is called also the superclass or parent class. And in the following example, of course, we discussed the example, the circle inherits the coordinates x and y and the methods. In addition to it has its own method. Before going through this discussion, let's just scratch a bit about the classes. Suppose that I have class A, all right? Or let's say okay, this is class A. A has attribute integer x, integer y, all right, and integer z. And I have another class, which is B, which has attributes integer x, integer y, and integer w. And I have a third class, C, which has integer x, integer y, and integer, whatever the name is, z. Z also is there. It will be the same. V. All right. So if you can see here, I need to define three classes. This is the first one, this is the second one, and this is the third one, which is correct. Absolutely correct. I will define it like this. Class A, integer x, integer y, and integer z. Don't forget the semicolon at the end of the class. All right, this is the first class. Then I have to define class B, integer x, comma, y, z, the same meaning. All right, then I have to define class C, Here I don't have Z, I have W, right? I have to define, I'll define integer X, Y, and V. All right? If you can see here, the three classes has few things in common, which is integer X, Y here, the same as integer X, Y here, and integer X and Y here. So, first of all, when you repeat the same class 3 times, you have repeated the declaration of these 3 times. All right. If you have 4 or 5 times, you have to repeat every time. So this is called redundancy. In Arabic means tikrar. All right. So this is redundancy. First thing. Second, if you notice that I've committed a lot of mistakes, by the way, here of errors. For example, here I didn't put semicolons, right? So how many possible error I may face here? 9 times, all right? But with inheritance, we reduce this, reduce errors, possibility of errors, 3. With inheritance, we'll make program shorter, right? The code will be shorter and easier to manage. So what I'll do here, I'll tell you what to do. First, I'll create a class. I'll call it S. I don't know why S, maybe because it's superclass. I selected this name. All right, you can select any other name. Next, I'll take all the common things between the classes and put them in this class. In this case, I have integer X and integer Y. So in the superclass, I'll define integer X, integer Y. All right. Then I will come to the classes that I have, which are class A, class B, and class C. This is A, B, C. If I go to class A, let's go to class A and C. In class A, I have X, Y, and Z, right? But X, Y can be inherited now from this class. Okay, so I need to define only the remaining, which is integer Z. Okay. Next, in class B also will inherit X and Y, and let's see what other thing, W. So I'll define only integer W. Class C, only integer V or U, I don't remember. Okay, so now with this structure, first of all, in every class I need to write shorter code. Okay, the possibility of error occurrence will be less. The management of the program itself will be very much easier. Okay, and there will be no redundancy. If you can see here, how many variables we have declared: 1, 2, 3, 4, 5, 6, 7, 9, 7, 8, 9. 9 variables, while here we defined 1, 2, 3, 4, 5. So we avoided redundancy. Till now, is it clear? Okay. Now, if I want to write it as a code, let me just add another slide. Okay, if you want to write it as a code, in the first case, if you remember, we wrote class A and we wrote integer X, integer Y, integer Z. Then I have class B and we wrote integer X, integer Y, and integer W. And then class C, integer X, integer Y, and integer V. All right. Again, don't forget, please, the semicolon here at the end of each class. It's very important. Now, with the new notation, I'll define it like this. Class S integer X and integer Y. All right, then I will not use this S directly. I'll write class A, but here I have to put colon, right? Then the superclass S. That means I'll inherit everything from S, and I can use them as if they are written or they were written in A. So here only integer Z. Class B inherits S. Okay, I'll write integer W. And class C inherits S integer V. Okay, so if you can see here, what we did here is we reduced the code in every class. So here in the class A, we only wrote one instruction, which is integer Z, and B also only one. How about others? It will take everything from here. Of course, I'm not talking about the access, because the access itself needs some lengthy discussion, because we have different kind of access. We have public, private, protected. This will be covered soon, but the main idea is like this. All right. So in this case, I think things will be a bit easier. The possibility of error will be less. The redundancy, I don't have like this here 1, 2, 3, 4, 5, 6 times. I wrote the same code, but here I wrote it only once. Okay, so why inheritance? Why inheritance? We will implement this code practically. Okay, now this is another example. Consider a group of employees. We need to create class for, let's assume that we have these 3 types of employees. All right, programmers, administrators. All right. 1 second. I don't like to keep things not correct. Administrators and HR personnel. Of course, I have others, but I will discuss considering this example. All right. So if you want to create a class for everyone, there will be a lot of redundancy. Like, let's see the method. Suppose that we have the method which is calculate salary or leaves, etc. Of course, there are so many other methods that are common between them. Some attributes, such as ID, name, etc., are common among all classes. Right? If we create these classes, avoiding inheritance, then we have to write all of these functions in each of the classes. So I have to, I think it's here, it's clear here. If you can see, here I have the programmer, has the attribute name, ID, field of programming, this is another attribute, and the method calculate salary only. I considered all this for simplicity. The HR, the attributes are the name, the ID, the responsibilities, and the method calculate salary. The administrator attributes are name, ID, department to run, okay, and calculate salary. So if you can see here, only this part is different between the different employees, and all of these employees, all of these classes are employees, right? And they have so many things in common, like name, ID, of course, some other. I don't want to go deeply in this, but we'll take only 2 or 3 attributes to make discussion easy. Now, if we could take the common attributes and methods and put them in one class, which is the superclass, and other classes can inherit these from it, then this will make program easier to understand and to follow and to debug, and reduce redundancy and reduce any chance of error. Okay, so this is the, instead of writing these classes, we can write them in this way. I'll define the superclass as personnel. I will add the attributes name, ID, and calculate salary because it's common. And then I'll define the rest of the classes. I'll inherit things from them. Okay. Programmer, field of programming, for example. Okay. HR, I will add only the responsibility and administrator department to run. All right. So this is another example. All right. Let's discuss first or implement the first example. So the first example here. Okay, or I'll write it first. Okay, so this is example 1, which is the A, B, C classes. So let's implement this. Somebody is talking with us. Hajar or no? Why Hajar is not with us? Sorry to interrupt, but I want to make sure that everything's okay. So Hajar is with us now, right? Okay.
Yes.
Very well. So let's get back to our discussion. Now, I'll define first the ABC classes as usual. Okay, we'll use this online. Okay, so I'll define A class A. Integer X, Y, and Z. Don't forget the semicolon again. Class B, integer X, Y, and W. Semicolon. Class C, integer X, Y, and V. So these are the 3 classes. Of course, these classes are doing nothing, just an example how to use them. Now, here, integer main. I can, for example, define A1, okay, B1, and C1. All right, all these are declared or declaration of classes. Nothing will be printed, nothing will be done because, as I told you, here we just declare variables. So if I run it, okay, there's an errors here. class expected name before class A. 1 second. Sorry. We don't have this. This is in Python. I'm sorry. These columns. In Python, they put columns. All right. So the execution was correct, and we don't have any issue. This warning, by the way, is telling us unused variable A1. That means you declared variable that you didn't use. No problems at all. Okay. So this is the first example. I will just share it with you. Okay. Just bear with me. I want to make it as short as possible. Okay, so this is the answer of the explanation of the ABC classes. Now the other thing is, till now we just created these classes, right? But now we didn't use the inheritance. So what I'll do now is to write the same thing with inheritance. Please follow with me the steps that I'm going to use or to do in inheritance. I'll go back to, oh, sorry, somebody is talking or texting. I don't know why I have. No, nothing. All right, so I'll go to the editor and I'll show you how to convert the classes using inheritance. So first of all here, I need to declare or define the superclass. I'll call it class, right? And in this class, I'll move everything which is common, like X, Y. X and Y, all right? What's remaining in class A? Integer Z only, right? But here, I need to tell the class that you are going to inherit from S, the features from S. Again, after I create class S, I will put whatever common between the classes that they are going to inherit things. So integer X and Y, correct? Then here, I will remove X and Y, integer X and Y from the class. But again, I have to inform the class A that you are going to inherit what I removed from the class S. The same with the class B. No need to write any more classes. Inherit things from S. That means X and Y are not needed anymore. Class C inherits from S, and you don't need X, Y anymore. All right. So this will do the same, or will work exactly the same as the previous class. So this, after inheritance, I'll share it with you so you can compare or see what we've done. All right. So this after inheritance. Okay, I'll put it here. Okay, so this is after inheritance. There's no big difference actually in such kind of simple programs, but in large program you will see the difference will be very big and very crucial. Okay. Now let's see how the inheritance, or let's see if we have. Yeah, we'll add another slide. How inheritance work? Let's see how inheritance work. So I'll start another example. I will consider only two classes, which are in this case A and B, okay, or S and A. I remove the rest of the classes to make code very short, or as short as possible. So here in S, I have X, Y, and A. I defined A only Z. Then I don't have here B and C. Okay, I'll add something here. Okay, which is a method. Okay, public print. Okay, which will see out X. Okay, X. It's just a simple function to print the value of X and Y. Okay, all right. Here also I'll close it. So now A, how many attributes does A have? Anybody can tell me? Class A, how many attributes? When I defined A1, so how many attributes does it have? Waiting for your participation. Again, my question is, I have this A, class A, inherits S, integer Z. So how many attributes the class A has?
Two.
Sorry, I cannot hear you. Speak louder.
Two.
What are these? What are the attributes? Anybody?
X and Z. X and Y.
Sorry, X and Y. All right. Almost there. Who else?
And Z.
And Z, exactly. So although, thank you very much. Who's speaking?
العذراء.
Who was? Adra, Adra, very good, Adra, way to go. Perfect. So, although in the class A, I have only Z, I've declared only Z, but actually it will inherit the value or the variables X and Y from the class S. So I can see here, I can write, by the way, here, A1 Z equals 5. All right? This is correct. Let's see. Of course, I'll get error, by the way. I just want to show you the common mistakes. So before executing, I'm sure we'll get errors. All right? What the error says? Error, expected colon before print. All right, this is the first error. because public should have colon. All right, still I have errors. The other error is, or let's read it here. Print error. Print with no type. Okay, so in this case it should be void. All right, no, not the big problem here. Okay, here are the most important error. Integer a z is private, and here it's say error within this context. You cannot access z because it's private. Why is that? If you remember, when we talked about the access of variables, we say we have three types of access, right? We have private, we have protected, we have public, right? So private cannot be accessed from outside the class at all, and by all means it's impossible unless you can access it from public methods inside the class. All right, so this is the first problem. Protected can be accessed by the by the class itself and from the inherited class, or sorry, the subclasses, the classes that inherits from the superclass. This is protected. Public can be accessed from outside. Basically, I will change this to be public, just for simplicity. Okay. Now if I execute it, yeah, perfect. So no errors. All right. Okay. But till now, I didn't access the other. If I use now a1.x, now as we discussed and we agreed that since a inherits s, that means x, y, and the print function, all of them are members or can use all these attributes and methods. Okay, so a1.x, of course, now I can use it, equals 7. I'll get error, by the way. Let's run it and see. Okay, error says that integer s, x is private. Again, I cannot access, although it's inherited, but since they are private, they cannot be accessed. Here I have to declare it like public. And if you remember, we said if I don't write this keyword public, private, or protected, by default, the attribute or the functions, the members will be private. Okay, now I will not get an error. I got an error. What is this? X is inaccessible. You know why? I will just take this and I cannot reduce the size. Okay, let me just take this and discuss it with you like this. Okay. Now, as we said, since the class A inherits S, that means it has access to X, Y, and to this function also. But still I have a problem, by the way. What the problem is? As we said, first I changed this to be public, and I changed this to be public, so they can be accessed from outside the class. If I write s.x equal 5, it's all right, no problems. s.y equals 7, it's okay. Okay, but what I did here, I inherit x and y, so I assume that I have here also integer x and integer y, and I have, of course, the void print. Okay, but when I inherit these things, I inherit the or the class A inherited everything as private. Why? Because the default is private. Remember this, please, always. the default is a private. If I don't write any keyword here, then it will be private all the time. And remember, we have 3 types. Again, private, protected, and public. The 3 P's: private, protected, and public. Private cannot be accessed. Protected can be accessed from the class itself and the derived classes, and public can be accessed anytime and anywhere. So for simplicity reason, we consider this as public, but still the inheritance type here is what is private. So to do this, or to overcome this, I have to change the inheritance to be here public. Okay. Now let's run it. No, perfect. Everything is perfect. So if I use a1.print, of course, if you notice that I give only the value of x, I didn't give value of y. So I think y will be either 0 or some rubbish. So 0, yeah. Okay. So when I called this function, it moved x to the original class, or the father, or the parent, or the superclass printed, and y is equal to 0 because we didn't give values. Let's give value. a1.x equals 9. All right. Now if I run it, I'll get 7 and 9 here. 9 and 0. Sorry, x here. Y. Okay, so I got 7 and 9. Okay, so this is the simple example of inheritance and how to deal with them, how to treat the access. It's very important to pay attention to the access. Access means private, protected, or public. Remember the 3 P's: private, protected, and public. All right, now let's see if I change the same class. All right, here, if I change the inheritance to be protected. Okay, this case, or leave it public. I'll change the modifiers access protected to be protected. So if I change that to protected, of course, there will be slides for every type and for every relation. So you need to read the slides, but I want to explain to you, then we will display the slides. Okay, if I change this protected, what's the meaning of this? All right, so I'll copy this. Okay, let's see the access. Here, protected, what's the meaning of protected? Protected mean can be accessed only by the class itself or the subclasses. I mean, if I write, for example, in the integer main function, I define, for example, S1. Okay? If I write S1 dot X, I'll get error. Why? Because X is protected. Okay? But here, if I use it in the class A, then it's accepted. If I write, for example, here, X, print X or cout X, this is correct. Why? Because since it's protected, That means X can be accessed by any method here and can be accessed by any method here, but not outside these two classes in the main function or in any other classes. All right, so this is the meaning of protected. If I use them directly, I'll get error directly, or I can use them inside the class and inside the subclasses. Okay. So I'll share this with you also. Yeah, from here. So this is an example of how inheritance work. Okay, I hope it's clear. I think that's it for today. Next lecture, we'll repeat this example about the point. Okay, and I have another example to share it with you. I'll see you next lecture, inshallah. But please read carefully, go through the material, and if you have any questions, please don't hesitate to ask me. I'll share this with you, please, and please don't print it. Don't print this material unless it will. We reach the last slide. I tell you, okay, that's it. I will not make any modification because we'll keep modifying it to update it to be better and better every time. Okay. Do you have any questions? Do you have anything? So I'll stop recording now.